Hello everyone, my name is Wang. It's a great privilege for me to share with you our exploration in the autonomous management of database. And my name is Wang Tao. And I once was an Oracle DBA, but with the title of IOE, I has transferred into my cycle DBA, and now I am a DevOps architect responsible for the Alibaba database management system, and in the hope of improving the stability and efficiency of the systems. So today I'd like to talk about four aspects. The first one is the evolution of this management system. The second one is the features. The third one is control capability. And the fourth is the business scenarios. So in 2003, we have been divided from the SA system. And in 2003, one of the DBA, if you could install the Oracle or the Oracle Rack, then it was a remarkable thing. And in 2006, we gradually started to develop the monitoring systems, and we used the Negos and the Kakati open source tools. In around 2009, we started to develop the first generation independently developed operation and management system at Beidou to replace the Negos and the Kakati. Why do we want to replace them? Because those open source tools will have several issues. The first one is that the individualized definition cannot meet our demand. The second one is that the linear expansion capability is not as good. So we started to develop our own maintenance systems. The second period of our evaluation is in 2010. We started to DIOE, and we developed the first MySQL system that is called Tianji, and similar to Oracle systems, it is focused on monitoring availability and backup, those basic functions. And as our business is continuously scale up in 2013 and the deepening of DIOE, our team had been scaled, and the pressure for MySQL operation had been bigger. So the second generation of the operation system is called DB3, and it focuses on the automatic operation and maintenance. You can take a look at the lower right diagram, and this is a single framework and one control platform. We've connected to a lot of MySQLs. And in 2016, that is last year, we have developed the third generation. It's called DB Pass. And why do I want to say that this is the third generation database management system instead of MySQL operation system? Because in the third generation, we not only support MySQL, but also Mongo, PG, and a lot of the other types of the databases, and we can provide services for Ali, such as the remote active, etc. There are several features for the third generation. The first one is that it is based on the microservices, and the mono framework is no longer suitable because our business had been expanded, and for 100% of the time you do not need to log on, and you can have a very automatic operation, and we have a very high availability with the tools of availability, and we can have a sustained verification for the availability of the backup. For some of the companies, they only have the backup capability, but we also have the backup efficacy verification. We can make sure that this backup is valid, and we will also have the company database management services as well as the monitoring services. And this is the architecture of this database management system. And on the lower left side, you could see that input areas. What are they? Such as the high availability, metadata services, operation and maintenance, as well as the backup recoveries. So through the task engines, we can have a unified scheduling, and through the task channels, you could execute those tasks. I need to point out that in the high availability, we did not use any task engines because we believe that high availability will have a very high requirement for the services and real time. So it is a direct link. So as long as we have the input part, we will definitely have the output part, that is the lower right-hand side, the green part. After we have collected the performances, we will push the data into the Kafka and GStore and OpenTFDB. So on the left-hand side, it's the input. On the right-hand side, it's the output. And in each square, we have a service. And in the middle layer, we have a service center, and the major function of the service center is to explore and identify the services. And then we can know where are our services, where we can use those services. On the right-hand side, the API gateway has the function of separating the front end and the back end, and we can have comprehensive verification and traffic limitation. So for the external systems, they will have a very limited access to the internal management system, and we can prevent any intrusions. And on this framework, you can see the positioning of our platform. And in the lower layer, you can see the resource scheduling, such as the physical machines, ECS and Docker. And then on the upper layer, we can see the database. And in the upper layer, these are the business layers. We have Alibaba and external companies layer. And in the middle, we have a dotted line in red. And this is the database management platform. And our role is to bridging between the business layer and the resource scheduling and database layer. We can realize a very quick deployment and distribution of the tasks. In this dotted square, we have 3 layers. We have the modules for maintenance, such as the CMDB, that is the metadata. We also have the monitoring collection and order channels. All of these are the repetitive works, and these are the modules and parts for maintenance and operations. And in the middle, we have the operation platform. So we will assemble the modules, and then we could have executions of the operation practices. And on the green layer, that is the corporate services, and this is what's distinctive about us. So we have so many services based on the databases and our business, such as the unit control, and we have the remote or offsite active services. We also have the disaster standby, and we also have the backup plan platform. And later on, I will also have some instructions about these services. So one of the important features of the platform is the second level monitoring. I believe that a lot of you has this question. The developer said that what was the status of the database? Actually, a lot of the system cannot tell you at a specific time point what had happened. And this was also the reason for us to develop the second level monitoring. But this kind of monitoring will have a lot of requirements for the database. First one is that the monitoring procedure cannot occupy too much host resources. It's impossible to make these monitoring procedures more busier than the host. And the second is that the client demand should be very, very smooth. And the third one is that we have a massive data. Suppose we have 1,000 MySQL cases, and each case will collect 200 indicators. And how many data will there be in a day? We have calculated that each day there will be 17.28 billion data, and every month we will have 518.4 billion. And how can we solve the problem of such a big amount of data? And how can we meet the previous 2 demands with such big amount of data? I will give you the answer later on. First of all, we could match the demand of the clients with the previous clients, and we need to restart the clients, and the clients should not occupy more than 1% of the total host resources. And we utilize the Go language features, and sometimes the language will be compiled and executed at the same time, but it's different for the Go language. And we also have a very low weight features of the Go, and it also make it performance better. And on the other hand, on the clouds clients, we need to have the pre-computing, integrating and a batch process. For example, I have collected I/O performance, CPO performances, the network and the database performances. So what should we do? The conventional practice is that we should collect in batch and report in batch, and the service and will receive multiple reports. But what we do is to integrate several reports into the single one, and the demand will be integrated from 6 to 1. So After we have collected the mass amount of the data, we will use Kafka and JStorm to conduct the computing. We have optimized both tools. The first one is the optimization of the parameters. And on the other hand, for Kafka, we have integrated the partitions. How to understand that? I have 128 MySQL databases, and in its cluster, we have 128 databases. And I like to integrate all of these databases on one node to be operated, so there will not be cross-point operation and scheduling. And as for JStorm, we have also optimized it, especially on algorithm and computing logics. And in the top model, we have also optimized it. As you can see on the cluster of JStorm, there are a lot of top systems, such as the DAM, Cloud DBA topologies. And before, it was the same topology, but there is a situation if it is a heavy task and if the algorithm is relatively slow, if the computing is relatively slow, then it will affect the total topology. So we have divided it into a lot of sub-topologies, and in each topology we can have isolated operations, so we can optimize the performance and make it most lightweight. As for storage, as I've mentioned, we have big amount of data, and we will use the sequential databases. And we have took advantage of several features of it, such as the time-only. And in the base layer, we also use the queue compression to guarantee that the storage performance and cost are the most optimal. So on the Y client, we also use the WebSocket. I believe that most of the cases will not use it, and most of them will use HTTP demand. What is the problem of HTTP demand? Suppose I have 10 clients and I would realize 1 second monitoring, and the DBA is usually low frequency. Then it means that in a service end I would receive 10 requests to have responses. But what is the practice of WebSocket? And in the service end, every second I will make a calculation, and then I will push the result to the client. So before we have 10 demand, 10 computation, but now we only have 1 demand and 1 computation. So we have shortened 10 times of the computation to 1. So we have conducted a lot of similar optimizations. Another thing is the intelligent alarming process. So the traditional alarming is that we will directly send the alarm to DBA. It is very direct and straightforward. DBA can receive the alarm at the first time possible. But there is a drawback of it. There is too many alarms, and it is overwhelming. And once the DBA's mobile phone had been vibrating all the time because it was receiving alarms all the time. So we should not view the alarm as a simple notification or a short message. We could view it as an incident drive, and through those alarm we can have a diagnosis, and then in its rule engine we can decide whether we need a diagnosis or not, and then in the case bank we can have more processes of those alarms, and then we can have the recovery. So if we have realized that it was caused by a facility, then we will have a cruise check, then we can prevent the same error to happen the next time. And of course, we cannot get rid of the DBA 100%. Sometimes we cannot process some of the incidents. So we should send the alarms to DBA from time to time. So by doing so, we can guarantee the availability of the system and accumulate the experiences of the DBA. In the other end, we could start to explore the alarm intelligent treatment. And through those practices, now we could get rid of the incidents of the errors before that is actually happening.
Another thing is about the architecture design. Because we have more control system modules, and for the machine room silos, it requires the internal service to continue to be available. If you have 3 machine rooms, if your machine 1A is down, you need to do something to ensure the database is safe. So we need to solve the machine silos problem. Another thing is that the zookeeper cannot solve the silo problem. If the B room is the silo, zookeeper cannot provide service. We need to solve that. Since it's a distributed system, we would consider about CAP principle. When we look at this one, I will not go to details. The CAP principle is either meet to CA, CP, or AP. It cannot meet CAP. It's very difficult. So we have base theory. The focus of base theory is to ensure basically available. First thing, the availability comes first. And for the softer state and eventual consistency, it can ensure eventual consistency. So base theory is suitable for the control system. And we can have the architecture design based on microservice. First thing, we conduct the architecture practice based on microservice, and we eliminate the zookeeper and use Eureka as the service middleware. Eureka is the service middleware for service finding and service registration, and the green parts are microservices. When the service is initiated, I will go to the service center for registration. When API gateway identifies the service and we identify services, then we can use that. The API gateway can use a microservice. So when your machine migrates or change the IP address, I can always find that problem. And the other one is about the physical architecture. And the green one is the Eureka server. In every machine room, we have Eureka server. And the data sync is done by Eureka itself. And in the left side, and we have application service in the left side and the lower side. And it will publish the service, and we can call that service. And the application client can get from the server the service address, like the application client, they can get any of the service because it's connected with the others. It can get service and operate correspondingly. And when the machine is down, the Eureka server is not connected with the other machine rooms, then it becomes a silo. Then the Eureka server will turn the other service offline, and its own service will still register on the server. And when the client gets the address and it finds the silo, so it can solve the silo problem and still can work together with the other machines. The other guests have talked about the hybrid cloud control, and with the wave of the cloud computing, during single days, we support the hybrid cloud flexibility, and we have also acquired companies like Yoku and Autonavy and Tudou. They also need to use hybrid cloud, and also we need to support internationalization of different TPUs. So the green part is the database hybrid cloud management. We can manage different nodes databases, and we have Ali's databases. I think in order to verify a control system, how is the hybrid cloud? There are several determinants. One is whether you can build site with one key. In the left side, we have the central database with one button. We can complete the offsite cloning. And in the right side, we have the tool platform. So we can have one key to build site, scheduling platform, resource platform. Maybe you would have some doubt why it takes us 3 days to complete the database setup. Actually, that includes the time for backup. And we have rich enterprise database service because we have accumulated a lot of services and experiences. Because we not only have basic operation, database control experiences, because we also provide database services like basic operation. We have equipment evaluating system, and we can test the different scenarios such as when the space is full or when the machine's down. And for DB Lab is the database laboratory. It's for pressure test. Why do we need to do pressure test? Although we have Sysbench, the biggest problem of Sysbench is do not have our business model. They don't know about our business circle. That's why we have 5 layers of LAM. And on our DB LAM, we can set up our business model. So our table, our data can be put there for pressure test. On the other hand, we'll also have server replay. We can simulate from Oracle to MySQL or to other systems. And also one key database setup and unit control, etc. Because of time limit, I will not go through them. This is about our development history. We go from monitoring, alarming, and then we go to scaled operation. And now we're in the phase of rich database services, and we are approaching hybrid cloud scenarios. So we want to create an enterprise level hybrid cloud. And it is not IaaS dependent, no matter it is on the cloud or not. It can manage any database. And there's no environment dependence. It not only supports MySQL, we also support Mongo, PG. It also has active operation, routine checking, and smart diagnosis settlement. So it has the self-operation. We also have rich enterprise-level functions like offsite, active, and disaster preparation drill. This is our business scenario. We're not only serving e-commerce, we are also serving overseas business. We also serve finance, Alipay, and also for courier, Cainiao, and also transportation and daily life in Thai, and also videos, entertainment, maps. Okay, that's all for my introduction. Thank you.